if we take a look at this first example, it says a ladder is leaning against the side of a house 12 meters above the ground. If the base of the ladder is 5 meters away from the house, how tall is the ladder? What's going to be really helpful for us? What we don't have that would be really nice to have to help us solve the problem? What? A diagram, a picture would be really nice if we had that. Well, we can draw one based off what they gave us. Okay? We have a ladder leaning against a house. So a house is straight up and down. And we have a ladder leaning against it. Okay? And then they're both sitting. They're not just floating into space. What's beneath the ladder and the house? The ground. Well, drawing that scenario, what shape did we just make? A triangle, specifically what type of triangle? A right triangle. So if you help you label, this is our house, this is the ladder, and that's the ground. Okay. Well, it's in the ladder is leaning against the house 12 meters above the ground. So here's the ground, here's the ladder. This whole distance is 12 meters. And it's saying that the ladder, the base of the ladder is 5 meters from the base of the house. How tall or long is the ladder? Well, if we have a right triangle, are we going to use trig or are we going to use Pythagorean theorem? Why are we using Pythagorean theorem and not trig? We don't have an angle. Very good. What else? We what? We're only missing one side. Okay. So we are trying to find the length of the ladder. Okay. So we're going to label with X. And we don't have an angle. That's a good indicator. That's a great indicator that you're not using trig. You have to have an angle. Also, we're given two sides. And when we're only missing one side of a right triangle, we can use the Pythagorean theorem. Which is what? So label, which side always has to be our C? The hypotenuse, which is a cross, so go across here, now you have to so make that my A, and that my B. And then fill it in. A is 5, our B is 12, and we don't know our C. Our C is X, that's what we're trying to find. Or you can leave it at C, it doesn't matter. So plug this in, 5 squared plus 12 squared is what? 5 squared is 25 plus 12 squared? 169. What do we have to do to both sides? The X by itself? Square root, and X is equal to what? 13. So the length of the ladder is 13 meters, because that's the units we're doing it. Questions over that? Number 2 says Owen walks to school every day. When Owen leaves his home to get to school, he walks 8 blocks north and 6 blocks east. What is the straight line distance from Owen's house to his school? Okay. Well, Owen starts at his home. So I'm going to put a point that represents home. And then he walks 8 blocks north. So which direction are we going to go? Up. North is upwards. So we're going to go north 8 blocks. So just kind of estimate. There we go. And then which direction he goes? He goes 6 blocks east. Which direction is east? To the right. Think never eat sour watermelon. So we're going to go to the right. We'll say. What? Soggy watermelon? I always learned soggy waffles. Soggy waffles? I was sour watermelon. That's what I learned. Never eat sour watermelon. Or never eat soggy waffles. Some people like soggy waffles. Okay. So then he ends up at his school. Okay. We want to find the straight line distance from his house to his school, meaning the very straight line. So whenever you hypotenuse. Because we just drew a right triangle. Straight line distance means what's the hypotenuse, or it is the hypotenuse. Okay. We went 8 blocks north. I'm going to label that with 8, and 6 blocks east. I'm going to label that with 6. And we're trying to find the straight line distance, meaning we're trying to find the hypotenuse. So I'm going to label that with X. Are we going to use trig or Pythagorean theorem to solve this problem? Again, why are we using Pythagorean theorem? Because we have both sides and we don't have an angle. So I'm going to do a squared plus b squared equals c squared. Which one has to be our c? Hypotenuse. Okay, it's across from your 90. Then it doesn't matter. We'll make that a and make that b and plug it in. And then plug it into our calculator. 8 squared plus 6 squared is what? 100. 8 squared, 64, plus 6, so right will be 100. And then what do we have to do on both sides? Square root. And the square root of 100 is? So it's 10 blocks. Is how far is the straight line distance from his house to his school. But he probably just can't walk that way because it's dangerous streets or other people's yards or things like that. Questions? Okay. Well, those examples all dealt with the Pythagorean theorem. Okay? Now we're going to start talking about examples that involve trig and using trig to find these missing pieces. But there's some vocab we have to talk about. And one of those vocab words is angle of elevation. And that's the angle between the line of sight and the horizontal when you're looking upwards. Okay? So here's our horizontal. And there's this like imaginary horizontal line coming out from this person's eyes. And his line of sight, he's looking up. Okay? And if you notice, it kind of makes a right triangle, right? We have a right triangle here. The angle of elevation inside a right triangle, okay, is at the bottom of that triangle up to the hypotenuse, up to the diagonal. And you notice how the arrow is going upward? Okay, so it's an angle of elevation. It's kind of like this bottom piece of a right triangle. And that's the angle of elevation. Angle of depression is the angle between the line of sight and the horizontal when you're looking downward. So we look here, we have this owl looking at this poor squirrel. Okay? So it's looking downward, so the diagonal is going down. There's this imaginary horizontal line coming up from that owl's eyes. If you start at the horizontal and work your way down to the diagonal, the arrow is going downward. So it's an angle of depression. Questions over that? The angle of elevation is always congruent to the angle of depression because they are alternate interior angles. Meaning, if we look at this diagram, we have a person looking up at the hot air balloon and someone in the hot air balloon looking down at the person. So they're sharing that line of sight. Right? This is the angle of elevation because if you go to the horizontal line and go to the diagonal, your arrow is going upward. It's the angle of elevation. The top angle is the horizontal. The angle of depression, because we start at the horizontal, our arrow is going downward to that line of sight. Right? And the two horizontals, the horizontal on the bottom and the horizontal on the top, aren't always parallel to each other. Okay? And the line of sight is acting as our transversal. So the angle of depression is an alternate interior angle to the angle of elevation, so they're the same. A lot of the times what you're going to see is something like this. You're going to have a right triangle. And the angle of depression is going to be on the outside. Okay? That's an issue because we need our angle on the inside. So whatever the angle of depression, this angle on the outside is, because it's the same as the angle of elevation, you can just slide it on right in this bottom part. Okay? But the angle of depression is always the same as the angle of elevation because they're alternate interior angles. And we'll see an example like that today. Questions over that? So take a look at example 3. It says a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. To the nearest tenth of a foot, find the height of the connection point on the tree. So we have our diagram. And if you notice, we have a right triangle right here. Are we going to use trig or Pythagorean theorem? Trig. How do we know we're using trig? We have an angle, and how many sides do we have? 1. Well, given. We do have 3 sides. You're right. Here's a triangle. We were only given 1 side. So we can't use the Pythagorean theorem when we only have 1 side. And another good indicator is that we have an angle. So we're more than likely using trig. Okay? So let's start at that angle. I'm going to circle the angle they gave us. And label, go across. That's our opposite. Go to our 90, go across. That's our hypotenuse. And the side left over is the adjacent. What else do we need to write down at the very top of your paper? SOHCAHTOA. We know we're doing a trig problem. I know I have to write down SOHCAHTOA. And based off what we labeled, which one are we going to use? Sine, cosine, or tangent? Yeah, why are we using sine? Yep. Our opposites are variable, our hypotheses are number. So we have to use sine. So I'm going to say sine of the angle they gave me, 42, is equal to the opposite over the hypotenuse, x over 8. To solve this, ask yourself, is x up high, down low, or the angle? Up high. So Trent, what are we going to do? Multiply. X up high, we multiply. So we're going to multiply both sides by 8. So then we get 8 times the sine of 42 equals x. And that's what you're plugging into your calculator. You're going to do 8 sine 42. And you should get that. Does anyone not get that? More than likely you're just in the wrong boat. Anyone not get that? If you didn't get that, let me know so you fix your calculator. So round to the nearest tenth, so it would be 5 point what? 5.4. And then we would label it feet. That's the units they gave us, right? Feet. And again, this is our angle of elevation because from the horizontal line up to the diagonal, it's going upwards, the angle of elevation on the bottom of your triangle. Okay. Questions over that? If we take a look at example 4, it says from the top of the fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? Well, are we going to use trig or Pythagorean theorem? Trig? Trig. Why are we using trig? We only have 1 side. And we have an angle. But where is that angle? Is that angle inside that triangle? No. But what we talked about on the front, they gave us the angle of depression. This is their angle of depression because we start from the horizontal, it's going downward. But what do we know about the angle of depression and this angle right here, the angle of elevation? They're the same. So if this guy's 40, what's this angle down here going to be? 40. So when that happens a lot, you just take whatever that angle is and stick it down to this bottom one, the angle of elevation. Now the angle is inside our triangle. Now we can use trig. Okay. So I'm going to circle that angle. Go across. That's our what? Opposite. Go to our 90. Go across. That's our hypotenuse. And the side left over. Adjacent. Yours is already written at the top. I'm going to rewrite it. But we have to use SOHCAHTOA. based off what we labeled, which one are we going to use? Sine, cosine, or tangent? So we're going to say tangent of our angle, which is 40, is equal to the tangent is opposite over adjacent, opposite over adjacent, so 45 over x. Ask yourself, is x up high, down low, or the angle? Is it up high, down low, or the angle? Good, it's down low, so what are we going to do? Switch around. So this whole tangent of 40 switches with the x. So this becomes x, and that becomes 45 over the tangent of 40. And that's what you're plugging into your calculator. So when you plug it in, it's going to be 45 divided by the tangent of 40. You should get that. The direction said round to the nearest tenth. So it'd be 53.66. 53.6. That's how tall or how far away he is from the ranger station base. Questions over that? And pay attention to what you're rounding to. You are asked to nearest tenth, nearest whole foot or whole number, nearest hundred. So just pay attention to what you're rounding to. Yes.
So I feel like 40, 50, like right angle, right by the 3. It's like 90 foot angle. I got the same answer, so that's still correct.
It does. I think it doesn't work. It might not work if you aren't given these things. I guess it would. You can think of it that way. Sometimes it might not necessarily be a 90-degree angle for you. That can work. Or the info you're given might not work out with that. But that works too, I think, most of the time. You're just not technically told that that's a 90-degree angle, so you just can't really assume. But it just happened to work out. Questions over that? Yes? No. If you forget to put a unit on that. As long as you get the process right. But take a look at this last example. This is a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest degree the angle the ladder makes with the wall. Well, are we going to use trig or Pythagorean theorem? Trig. Well, why are we using Pythagorean theorem when we're given two sides? Very good, because we're finding an angle. The Pythagorean theorem doesn't help us find angles, it only helps us find sides. So we have to use trig. We have to use SOHCAHTOA. Okay. So I'm going to start with the angle they gave me, the angle we're trying to find. And then label based off that. If we go across, that's our what? Opposite. Go to our 90, go across. Hypotenuse, our ladder is acting as our hypotenuse. And then side left over, adjacent. The walls are adjacent. Based off what we labeled, are we going to use sine, cosine, or tangent? Which one? Tangent. Yeah, we have our opposite, we have our adjacent. That's the info they gave us. So we're using tangent. We're going to say tangent of our angle, which is x, is equal to opposite over adjacent, so 6 over 15. So then ask yourself, is x up high, down low, or the angle? It's the angle. So it's not a curse, we use the inverse. So essentially what we're doing is just taking the tangent, inverse of tangent on both sides. That cancels it out, and we're left with x. And this is what you're typing into your calculator. To type it into your calculator, what do we have to press first? Second. Good. You have to hit second, and then tangent, and then type in that fraction. So you should get that. If you were to round to the nearest whole number, rounds to what? 22. Oh, just the trig ratio. The fraction stays exactly how it is. It's 22 degrees. Yes. Nope, because it said round to the nearest whole number. So you don't have to put, if it said round to the nearest 10, and like it bumps up to a 0, then you would have to put the point 0. But nearest 10, we don't have to put the decimal point. But good question. Questions over that. It's really what we've been doing, just adding a picture to it instead of just a regular old triangle. Some things you might have to draw on your own. Okay? Questions over that? No? Okay. The rest of the time is yours to work on